In this video, we're going to study rational exponent. So before we start talking about rational exponent, let's review what is the exponent. So we have 8 squared. The 8 is the base. The 2 here is called the exponent, index, or power. Now the exponent of a number say how many times to use the number in multiplication. For example, in this example, we have 8 squared, which means 8 times 8. So in word, we say 8 to the second power, 8 to the power 2, or 8 squared. Now, what does it mean by a rational exponent? Rational is a fancy name for fraction. So an exponent, the exponent of a half is actually the square root. For example, if you have 4 to a half, they actually mean the square root. So the in here is how we rewrite it. This is the old way to write the square root. Now we just rewrite like this. Now if you have 4 to the 1/3, then you would write as the cube root of 4. You have 4 to the 1/4. So for the exponent of 1/4 here now means you have 4 roots. So now when you have the fractional exponent, just know where to write a radical number. See, it's a radical number. Okay, remember this means index here. The power also means index. So here is how we generalize this. This is mean the index. Okay, and this is mean the radical symbol. This is a radical symbol. A radical sign. And the A inside here is called a radicand. Okay. So that's here. So you're observing that the denominator is actually your index. So let's look at the definition. A rational exponent, if n is an integer such that n is equal or greater than 2, and if you have the n root of a is a real number, then a to the 1 over n can rewrite as n root of a. So remember the denominator of the rational exponent is the index. Now, if n is an even number, then a cannot be a minus. If n is an odd number, then a can be any number, like it can be positive or a negative number. Let me show you some example. So I'm using this rule here to rewrite the problem. So look at, it's 81 to 1/4 power. So you have to rewrite as 4 roots of 81. Now you may ask me what happened to the 1 in the numerator. That is right there. Because 81 to the 1 power is 81, so we just don't write the 1 there. So now we simplify this. You're looking for a number that rise to the 4 power equal to 81. The answer is 3. If you cannot see that, and then the easy way to do is 81, break it down to 9 and 9. 9 is 3 times 3. This here also 3 times 3. So the 4 roots of 81 can rewrite as 3 times 3 times 3 times 3. So you see I have 3 to the 4 power is 81. Therefore the cube root of 81 is equal to 3. So here's the answer. Okay. Remember, you have 2 square, which is equal to 4. From here to here, you square, you got 4. But when you go backward, the square root of 4 is 2. That's how you should think of the square root. It's the opposite of an exponent. You have 2 to the 5th equal to 32. From here to here, you do the exponent. But when you go backward, the 5th root of 32 is 2. Okay. So let me write down here. So from here to here, if we have a square, and when you go backward, you have a square root. So from here to here, you do the 5th power, and go back with the 5th root power. Let's try another example. Now I have 32 x to the 10, the whole thing to the 5th power. That means 32 and x to the 10 is the base. So you have to write like this. Change the color. You put everything inside the radical. Okay, the 5, which is the denominator, is your index. And then you simplify. So the 5th root of 32 is 2, because we know that 2 to the 5th is 32. So when you go the opposite, is the 5th root is 2. Now for the variable, you take 5, divide the 10 here, do 2 times. Okay, the answer. Next one. So here we will write 16 x to the 7 and go to cube root. Alright. Now 16 is 8 times 2. 8 is 2 times 2 times 2. So we can rewrite this as the cube root of 2 times 2 times 2 times 2 x to the 7. Now the 3 here means we group by 3. So this whole thing here come out the 3, 3, 3, which is 3 to the cube, come out as 2. And this 2 here stuck inside. This 2 here stuck inside. Okay. Now for the variable x to the 7, you take 3, divide inside 7. 3 go inside 7 how many times? 2 times? You have x squared. And the remainder, which is 1 plus whatever you do. 3 goes to here 2 times. So you have this 2 here is x squared, and the remainder is 1, so you have 1x. That's how you simplify this problem. Let's look at the next definition. If a to the m over n and m and n are positive integer other than 1, then a to the m over n can rewrite as the n roots of a to the m. So the denominator is your index and the m as Mary is inside here. Or we can rewrite like this. Now, this last form here is easy to use and it helps a lot when you want to simplify. This one looks nice, but this one is when we use a lot when you simplify. So let me show you some example. I have this example. Now, this is the minus here means the whole thing is minus. The 8 is actually the base, and the exponent is 4 over 3. So to rewrite this into the radical, here the minus, the q is 3 here, and 8 to the 4. And then you simplify. Now, to simplify, I will rewrite like this, to look like that. So I put minus the q root of 8. Make it a little bigger. And then to the 4 power. Okay, because if you use this here, you simplify 8 to the 4 is a very huge number, and then the q root, so it's harder. So easy to use this last formula here to simplify the radical. So the q root of 8 is 2. And then 2 to the 4 is 16. So your answer is minus 16. Now, next example, you have 3x plus 7. The whole thing is the rise to the power of 7 over 3. So 3x plus 7 is your base. So when you write this into the radical notation, you have 3 is the outside. You have 3x plus 7. And then the whole thing here is 7. Now, if you notice that this example is a little bit different from this example, when I have a brackets like so, that means the whole thing is a base, you put in that. But here I have no brackets here. This means that this here, the minus here means the whole problem is a minus. The 8 here is your base. So you put the 8 inside only, not the minus 8 inside a radical. Okay. Now we continue to simplify. If the index here is smaller than this power here, you can simplify. Otherwise, you cannot simplify. So if this number index here is greater than the exponent here, then you cannot simplify. But if this number here, the index is smaller than the exponent here, then you can simplify. This here, I know I can simplify. And we do the same method. Because this is a variable, you can see this is a variable unknown here. Take 3 divide inside 7, which is 2 times. You have 3x plus 7 square. And we have 1 remainder left, so we have 3x plus 7. And don't forget to put the q here. Okay? Here is multiply. Let's do next topic. The definition of a to the minus m over n. Now, we do not like to have minor exponent, so we can rewrite this as a positive by put 1 over a to the m over n. This is very similar to the exponential law that we learned from the past. If you have a to the minus n, we can rewrite as 1 over a to the n. In this case here, our exponent is a fraction instead of whole number, instead of real number. So this here, I have to rewrite this to a positive exponent by putting 1 on the top, and 64 to 2 over 3. Then we continue to simplify. So the 3 is our index, it's q root, then 64. Okay. Now I like to put a square outside. I'm going to simplify this. The q root of 64 is 4, because 4 to the q power is 64 I mean. 4 to the q is 64. And then now, therefore the q root of 64 is 4. Now you have 1 over 16 is the answer. Let's try the next example. Now we will have minus here and there's no brackets. That means this minus here tells us the whole problem is a minus. 16 is the base. So I'll put a minus here. 1 over 16 to the 5 over 4. Now, what I did is here, when you put a 1 over the column, you change this exponent to the positive. But this minus right here is still the same. This minus here tells the whole column is a minus. So you only change the exponent. So when you rewrite this, you change the exponent to the positive by putting it down this way. Now we're going to rewrite this again. The 4 root of 16. And once again, I put a 5 outside like so. Now the 4 root of 16 is 2. This whole thing here equals 2. And to the 5th power. So I have 32 on the bottom. Okay, let's go to the next topic. This example here, we're going to look at the property of the exponents. We learned that a to the m times a to the m is equal to a to the n plus m over n, where m and n are a real number. So look at this column. And then, I cannot use this property here. So we also learned that if a times b to the n, where n is a real number, I can rewrite as a to the n times b to the n. So I cannot use the first one because to use the first property here, we make sure that the base is the same. Since the base is 32, this base is x, so I cannot use the first exponent, first rule. But the second rule says that if you have a times b to the n, where n is a real number, I can rewrite as a to the n times b to the n. So let's rewrite this as 32 to the whole thing here to the cube power times 2 to the 3 to the cube power. And then we're going to simplify more. Now, we also learned that if a to the n, the whole thing to the m power, we can take n times m, where m and n are real number. So you take this 1/5 times 3. You have 32, so which just mean 1/5 times 3 is mean 3 over 5. This is 3. 3 over 5. And for over here, you take 2 over 3. 2 over 3 times 3. So you use, which is equal to the 3 here and the 3 here can cancel out, so you have 2 left. Okay, and then let's simplify this by rewriting to a radical. So to have a 5th root of 32, and then to the 5th to the cube power and x squared. And when you simplify, we got the 5th root of 32 is 2, and you square, and the cube, which is, I have 8 x squared. Okay, let's try next example, last example. Now, to simplify this problem, I see that I can use the first property because my base is the same a and a here. So I'm going to use this property over here. It's a product property. They say when you have a to the n times a to the m, as long a and a here is the same base, we can keep the base at the exponent. Well, why not do that? Keep the base common a, takes 1 over 4 plus minus 1 over 2. And this denominator here, just copy over. We do step by step. Let me write a little bigger. So you have 1, 4 plus minus 1 over 2. Don't forget, looking for LCD here. LCD here is 4, so I have times 2 here and times 2 there. So I have 1 over 4 minus 2 over 4, which is equal to minus 1 over 4. So right here, when you simplify the exponent, I have a to the minus 1 over 4 over a to the 2 over 3. Now, there is now a property, it's called the quotient property. It say, let's do different color. You have a to the m over a to the n. As long as the base is the same, which is a and a, we keep the common base, take the top exponent minus the bottom exponent, which is m, where m and n are real number. That means it can be a regular, a positive integer, or fraction, or whole number. So here we can, the rule apply the same thing. Same over here. So I have the exponential number divided by another one. The a here, which is our base. We have the same base, so the rule here apply. We keep the common base, take the top exponent, which is 1 over 4, minus the bottom exponent, which is 2 over 3. And then now we simplify the exponent. Let me rewrite this. So I have minus 1 over 4, then minus 2 over 3. The LCD here is 12. So I times and 4 here, 4 on the top also, over here we times 3 times 3. So I got minus 3 over 4 and minus 8. 12 and 12. So you have minus 11 over 12. So now these two here become minus 11 over 12. Once again, we do not like to have a minus exponent. We write this as put 1 over a to 11 over 12. And then let's see if we can rewrite this into a radical notation. This has 12 roots of a to 11. Okay, now because the index here is bigger than the power here, we cannot simplify. Our answer is like this or like this. Either or the answer is. So if the denominator is bigger than the numerator, you cannot simplify. Right? In other words, if the numerator is bigger than the denominator, then you can simplify. And to do that, you have to rewrite to look like this and you simplify.